Welcome class. This is video number 2 on our bridge project. I'm going to open up the bridge software. Wait for it. I'm going to do a quick review of where we were. We're going to create a new bridge. We're going to skip screen 1. We're going to skip screen 2. If you didn't see the first video and you're lost by now, you should watch the first video, which was put out there Wednesday. Okay, I want to show you something new today. I'm going to show you how to use arch abutments, which we haven't done before. Okay, arch abutments, if you notice, create an arch. Depending on what you do here with the height of the arch, different things happen. Okay, but what I found is it's a really pretty good way to do a very cheap bridge. I'm going to go kind of halfway down, and I'm going to do an arch all the way up. If you notice, this is a pretty cheap price, and the reason is we're not taking all this dirt away. Okay, we're holding the dirt back with what's called a retaining wall. You're really taking this dirt, putting it right there, so you're really not moving any dirt away from the site. But this wall needs to be reinforced with metal right here. Okay, because otherwise all this dirt, when it gets wet, wants to blow through that wall and make the wall explode. So I'm going to show you how to do that. Okay, so remember, we're using arch abutments as a test here. Playing with the height, I made the height all the way up, and I'm going to show you how to do that. Okay, if you want to play with concrete strength, I think high strength could save you some money. It's a little bit more expensive, but it might let you save money on steel. Okay, and this is not going to help you, so I would just leave it right where it is on standard. Finish. Okay, here's our bridge. I'm going to start again by putting in the connectors, which look like dots, and they're called joints because they join the long pieces of metal. The long pieces of metal are called members. Okay, if you notice, as I'm doing this, these are all bar steel, solid bars of steel. Okay, solid bars of steel are really heavy and therefore really expensive, but they're also strong. I have to connect these dots on the side of my bridge because without them, this concrete won't be strong enough. These are pink right now because they're too long and skinny. Okay, this is called the slenderness ratio, and it's way too skinny. So I'm going to put in some more connectors, and as soon as I did that, this became two shorter pieces and was now allowed. Okay, I also have to do that over here. So I'm going to just put one there to line up with that dot, put one here to line up with that dot. I'm going to delete. I'm going to connect this all together with triangles because triangles are what you want. Remember, triangles are the only stable shape, so that's the only thing that's allowed. Okay, if you get an error message telling you like this, telling you that it's not an allowable shape, test with the blue button. Oh, this worked. It allowed it, but look at that. It did horrible. I'm surprised it even allowed the test because you saw there was a square there. Right here. This is bad. Okay, I'm going to put another line across it. And without even doing anything else, I'm going to test it because I think that'll already help a lot. Notice it helps a lot. But the weight of the truck made this fail in compression. Steel almost always fails in compression. And there's only one bad piece. So I have two choices. I could add another connector in the middle, make the pieces of metal shorter and therefore not needing to be as strong, or I could thicken it. Okay, I could just click on this one, and instead of making it 140, I could make it like 160. Okay, and I'll do two different designs on the two sides to test it. Blue button, green arrow means good. Okay, it works, but it's way expensive, so that's not going to win a contest, and it wouldn't really get you the next job. You'd probably not be hired for the next job because you spent way too much money. So the fastest way to save money is to change all these solid bars of steel to hollow tubes of steel. Okay, they're still square in section, but they're called tubes because they're hollow. And I'm not going to change the size or anything. Right now it's at 180. Okay, let's just, well, I know it's going to fail actually at that price. Let's just go a few clicks bigger, 2 clicks. 160 millimeter, $197,000. We'll test it. Okay, it's going to fail, but it's holding up its own weight, so that's a good start. Again, it failed in compression. 2 bad ones is all. Click, command click, make this a couple clicks bigger, test it again, and now look at that, and it's under $200,000 already. Okay, you can see these are really dark reds. They have a lot of force on them. They're near failure, but they're good enough. You'd get, and then these are almost failing in tension because they're blue. So they're trying to rip apart. So what I could do is I could go back now to save more money and start looking at these numbers. Okay, if I rank these in compression from 0 to almost 1, these have almost no compression on them, and then they have some tension on this side. So if I look at 0 on one side and I say, okay, anything below like 0.5, I'm going to make skinnier. I'm going to assume that that is pretty safe and I can save some money. So I'm looking at numbers here. I'm going to do those. I'm going to go like 2 clicks smaller. I saved $4,000 and it still works. Okay, it's getting a little more sagging in the middle, but it still works. And remember, this is not really this saggy. Okay, if I open this up here, I can turn off the exaggeration and it barely moves. Bridges do move when you drive over them. The next time you're in a car and you stop on a bridge because of the traffic, you're going to feel the bridge moving. It's kind of spooky. It feels like an earthquake, but it's totally normal. I like turning it on because I can see what happens. Okay. So you could keep playing with these numbers. Another thing I could test, I could put another piece of metal across here, across there, and that's going to let other pieces maybe get thinner. Now I know it's going to work. Oh, that's weird. That actually, I added steel and it made it fail. I was not expecting that at all. So that's a bad experiment. So why don't we just delete those? I can't believe that happened. That's really weird because look at, you take off the steel, it gets cheaper and it works. Pretty cool. So that must have transferred force to someplace else that then made it fail. Pretty crazy. But I want you to experiment like that. Okay, that's the whole goal in this project, is to experiment, experiment, experiment. Make sure you save every time you have a good bridge. You save with the save button. I usually name it by the price. So this one will be called 19437. 7 with rounding. Save it on the desktop, hit save. And that could be a bridge that I could hand in later for a grade. Okay, that's it. See you next time.